Hi, welcome to Thiru Academy. Today we are going to discuss about API gateway as we have discussed in previous video. Okay. To discuss about API gateway, I have already created one project which is called Cloud Gateway. Let's see what are the dependencies I have included in this Cloud Gateway application. Okay. See, dependencies are Spring Boot web dependency. Let's make it reactive. Why? Because in implementing of resilience 4J, we have used the reactor. We need to, for some features, we have used the reactor dependency. That's why we need to make it entire dependencies are, we need to maintain the dependencies in reactive only. Okay. And our application is also reactive application. This is Cloud Gateway is. Okay. This is Spring Web dependency which is reactive, and this is Spring Cloud, and this is the gateway dependency we have used. This is the Eureka Discovery client dependency. Okay, other than that nothing is there. Okay, when coming to properties, here see in properties, Spring application name I have taken as Cloud Gateway and port is 8080, and the application type is reactive, which I have mentioned. The property spring.main.web application type is reactive, I have mentioned. Okay, fine. When coming to YAML file, here I have used YAML also. Why? Because to show that in Spring Boot application or any other application also, Java application, we can use either properties file or I can use either only YAML or we can use both also, to specify that one. Okay, in YAML file I have mentioned the some properties which is Spring Cloud Gateway routes, where we are sending request through API gateway, right? First we need to forgot to discuss about what is gateway and all. Okay, yeah, come, what is API gateway? What is gateway? API gateway is a pattern. This is the design pattern or component, whatever you want to call it, you can call it. And what is the use of it? Routing request from clients to different microservices. Whenever we are sending requests to services, that request is routes to API gateway. Okay, what API gateway will do? What it will do is API gateway acts as a single entry point. Just now we have discussed for clients to interact with various services, to whatever the services we are sending, or to services we are sending requests, right? That every request needs to traverse through API gateway only in microservices architecture. API gateway handles tasks such as authentication, authorization, load balancing, and routing requests to the appropriate microservices based on the request path or other parameters. Based on the parameters, it handles like authentication and authorization. Load balance is also maintaining routing. These are all types. It is API gateway will do all types of work. Okay. Key functionalities are routing, load balancing, authentication and authorization, and request transformation, rate limiting, and logging and monitoring. These are all the functions done by the API gateway in Spring Boot microservices architecture. First one is routing. It routes the request to appropriate microservice based on the request path or other criteria. Okay, it maintains the load balancing also. It can distribute incoming requests across multiple instances of a microservice to ensure high availability and scalability. API gateway will balance the load balancing of requests also. Whenever we are sending heavy request to that application, there may be a chance of its crash of that application. So API gateway maintains the load balancing, authentication and authorization. Gateway can handle the authentication and authorization for incoming requests, and maintains the security policies also before forwarding the request to that service. Okay, then come request transformation. It can transform requests and responses to match the interface expected by the microservices, hiding internal details from the clients. It hides the internal details and transforms the request to other service through API gateway. Rate limiting. API gateway can enforce rate limits on incoming requests to prevent excessive usage of the resources. It can prevent the excessive usage of resources. Logging and monitoring. It can log the requests and responses for monitoring and auditing purposes, providing insights into system performance and usage patterns. Okay, it can monitor the requests and responses for logging. Okay. Yeah, coming to application, here for routing, through API gateway request is coming. How we need to inform to API gateway, this is the request comes through API gateway, and this request needs to transform to this microservice, right? This service. We need to specify that properties or information or metadata, whatever you want to call. Okay, we need to provide that data in API gateway or cloud gateway. That's why we are specifying these properties. Spring Cloud Gateway routes ID. If it's order service, we have discussed order service application, right? That application name ID is order service application name, and URI is load balanced of order service. If the URI mentioned in that URL is order service, if we have that order service, that we needs to check that path also. Path, if the order slash any request comes, we need to send the request to order service application. Okay, same way, if we have the path like product service slash product, that request needs to send that product service application. This is the ID of that application routes, then ID product service, then URI contains product service, right? So if we observe that product service in URI, we need to send the path also we need to recognize. So service name slash product, if we found, we need to send the request to product service. Like that, we need to mention whatever the services available. We need to mention that services here. Whatever the request we need, we send to that services. How many services are there in microservices architecture? We need to mention. Okay, fine. Like this, we can specify the routing information in properties file or YAML file. Okay, then come to implementation. Nothing is there to implement in cloud gateway or API gateway. This is one of the client in service registry. We need to mention, we need to specify, right? That's why I have used @enable discovery client annotation and Spring Boot main class. Okay, I'm running this application and we'll see the flow of that. Okay, we'll test this application, how API gateway is working in Spring Boot microservices architecture. Okay, yes, all applications are up and running. Now we'll test through Postman. Okay, our cloud gateway is running on 8080 port. Okay, let's come 8080 slash. First we'll send to payment. Okay, we'll check payment. For payment we need to send the order ID over here for the payment service request for get payment details. Okay, let's see the ID in payment details table. Yes, order ID 4052. Okay, same order ID I am sending here. Sorry, yes, we are getting the response. Payment ID is 102, order ID 4052, and remaining details you can verify. Okay, fine. Now we'll send to order service. Okay, to get the order details. Yes, for the order table, yeah, latest is 4052 order ID, right? Same order ID I am sending. Okay, for the order 4052. Fine. Port ID we need to change 8080. Fine, right? We need to get that order details, entire details. Yes, order ID 4052, product ID, quantity, amount. You can verify all the details. What happened if we send the wrong order ID? Okay, see message, order not found with order ID. Order not found is a error code. Okay, fine. API gateway is working fine. Now we will discuss about fallback mechanism. Okay, yes, fallback mechanism. By using circuit breaker, we can implement a fallback mechanism in Spring Boot microservices architecture. Okay, what is circuit breaker? We'll see. Circuit breaker is a design pattern that enhances the resilience of our application, particularly when dealing with microservices architecture. It is a design pattern and it enhances the resilience of our application. That means whenever we send a request to our service to API gateway, in case if its service is down, we need to send some request, right? Some of the service is down, so that not able to send the response, we need to respond back to our request, right? To specify that type of functionality, we need to use circuit breaker. Circuit breaker acts like an automated failover mechanism for external service calls. Okay, whenever we send request, if its service is down, then automatically it will send the response, that is failover mechanism. Okay, how circuit breaker works. Circuit breaker, first it is in closed circuit. Initially, the circuit breaker is in closed state, allowing your application to call external services as usual. It allows the calls to request services. Okay, that is the initial state of the circuit breaker. Okay, then failures trigger tripping. Okay, if a configured number of consecutive calls to an external service fails, the circuit breaker trips. Okay, whenever we are sending keep on request, if it fails, right, service is down or something else, network issue, if it fails, it trips. Okay, then it will come to open state, that is open circuit. Okay, in the open state, the circuit breaker prevents further calls to the external service. It won't send the request to external services for a predefined period. Okay, for a period of time, it won't allow the calls whenever circuit breaker is open state. Okay, instead it executes a fallback method which we define. Okay, which might return default values, notify administrators or take other appropriate actions. It will notify and all, it will do that work as usual. In addition, it is in whenever it is in open state, come here, I'll explain. Yes, whenever it is in open state, it won't allow any calls. Okay, default it will send the service is in risk or service is down, whatever we will specify, it will return. Initially it is in closed state. Okay, after whenever calls are keep on sending, whenever the services are fails, okay, it trips to it's changed to open state. Then gateway won't allow, API gateway won't allow the request calls to other services which we mentioned, which we have in our microservices architecture. Okay, then after a over period, after some time, whatever the period we mentioned, after some time it changed to half open state. Okay, at that moment when the circuit breaker is in half open state, it allows only limited number of calls, okay, to that services. Okay, then at that moment if it fails, it automatically changes to open state. If the calls are getting success or it sending back the response sending back properly to that service calls, then it will change it to closed state. Otherwise, if the services are failing, then it changes to open state again. Okay, I think you got my point. Initial stage of that circuit breaker is closed state. Whenever the service fails, it comes to open state. Then after some period, it changes to half open state. In this half open state, when services are fails, it get back to open state. Or services are returning back or sending request back to that request, it changes to closed state. Same thing here I am explaining. Okay, half open state. Just now we have seen, right? Success resets the circuit. If the half open state, after a timeout expires, the circuit breaker enters a half open state. It allows a single call to that external service to see if it has recovered or not. If it is recovered, then it recovered, it changes to closed state. If it's not recovered, it changes to open state. Okay, success resets the circuit. If the single call in the half open state succeeds, the circuit breaker resets to the closed state and normal calls resume. Just now we have discussed continued failures, keep it open. If the single call fails in the half open state, the circuit breaker remains in open state for another timeout period, preventing further unnecessary calls. Okay, just now we have discussed benefits of circuit breaker: improved fault tolerance, enhanced resilience, reduced load on external services. Okay, improved fault tolerance. They prevent your application from cascading failures by isolating issues with external services. It is preventing our application or service from the failures. Enhanced resilience. By implementing fallbacks, we can maintain a degree of functionality even when external services are unavailable. When implementing fallbacks, what will happen? If the service fails, we are sending response back to request. Okay. Reduced load on external services. By stopping unnecessary calls during outages, circuit breaker avoid overwhelming already struggling external services. Then whenever service is done, then what is the need of sending the request? Keep on. Okay, so at that moment, reduced load on services. Thank you. Yes, come here. We will implement the resilience 4J. What is that? Is circuit breaker in our Spring Boot microservices architecture. We need to import. We need to get that resilience 4J dependency. If it's a reactor application, we need to mention that reactor resilience for a dependency. Okay, then come new class, controller class. I am creating first class name I am specifying as fallback controller. For this class I am specifying as @rest controller. We need to get requests. Okay, that's why here I will specify some methods for that services. Okay, public string we are returning order service fallback. Method name I am mentioning like that. Return whatever the message you want to send back, we need to write it here. Order service is down. Please try after some time. Okay, fine. Yeah, this is get request get mapping. URI I am mentioning as order service fallback. Okay, fine. Like that I am mentioning for 3 services also. Yes, our controller is ready with our fallback methods. Yes, come here. Here in application.yaml file, we need to implement some filters here. We need to provide some properties. Okay, filters we need to apply. Yes, like this. After predicates, we are providing filters. Filters name, circuit breaker I am providing, and arguments name I am providing is whatever the application name or service name which we have provided in individual services, we need to provide here. Order service. Then fallback. Fallback URI we need to specify here. Forward : / whatever the URI we have mentioned in fallback controller, we need to specify over there. Okay, not here, here. Okay, same way we need to provide these filters to other IDs also. Okay, after predicates we need to provide. Yes, here this is product service. This is payment service. Yes, fallback URI also we need to modify, right? Yes, for this we need to modify product. For this we need to modify as payment. Yes. Yeah, after providing these properties information, we need to provide some configuration in Java level also. You can provide here also, fine. Otherwise, you can create one more class. Gateway. Yes, gateway config class I am creating. Yes, come here. When coming to Spring documentation, yeah, Spring Cloud Gateway, you can find the information how we can provide. See, route locator, custom route locator. This method directly I am using. Okay. Yes, I did some modification to that. Come here. In main class they have created, but here I have created some separate class, right? To create the bean for this class, I am providing configuration, annotation, and for routes we need to send that information, right? For which of that service need to call which URI, right? For this I am providing this information. Okay. Here predicate specific path. If in path if it's found order service, we need to use that load balancer of order service. Here for this order service, what we have provided that URI, for this URI it needs to find out that this path after order, then /*, any request comes with that order / we need to send to order service, right? So that information we have provided in gateway config. Okay, fine. You can find this class information in Spring Boot, Spring Cloud Gateway API documentation. Fine, right? I'll run this application. I'll restart this application. Then we will see. We'll test that application. Yes, Cloud Gateway is restarted successfully. Now we'll test our application. through postman. I am sending the wrong ID. We are getting that 503 service unavailable. What will happen if we send the correct ID? We'll see. We are getting that response, right? See, for the payment also we are getting. Okay, I will stop that one service. Okay, payment service I am stopping. Okay, fine, it stopped, right? It is, I think it is restarting. Yeah, I have stopped. I am sending request again to payment service. We'll see, it is getting internal server error. We'll see. Yes, come here. I don't do nothing. I have restarted all the applications and given some time. Okay, to register with service register. Then I am testing. See, payment service is down, right? Payment service is down. Please try after some time. Now I am stopping the order service also. Okay, fine. Order service is also down. See, I am sending request to get our order details. Yeah, order service is down. Please try after some time. Now we need to implement our circuit breaker in order service application also. Okay, fine. We'll see how we can implement it now. As to implement that, first we need to add resilience 4J dependency in pom.xml file. Then I am updating the project. Before that I didn't update it, so that we are getting exceptions. I am getting so many. Okay, so I am updating the project. Fine. Circuit breaker is a dependency added in our order service application. Then here we are using thin client, right? Come here. For external services, we have mentioned the interfaces, right? For payment, to call that payment service, we have created one interface with that methods in order service, right? For that, here I am using @circuit breaker annotation. Then we need to specify that name for that breaker. Okay, event. I am calling it as external. Okay, fallback method. One method we need to specify to send the response back to our service. Okay, so fallback method name I am providing as payment service fallback. Method name we need to implement it now. See, come here. In interface we can provide one default method, right? So for that default method I am implementing here payment service fallback, which is returning. See, I am sending request. Sorry. Here I am specifying the message like payment service is down. Please try after some time. Not available is the error code I am sending. See, in order service we have implemented that order service custom exception. So I am throwing that order service custom exception. Throw new order service custom exception and error message and error code we are sending whenever we are calling that fallback method. Okay, same way I have implemented in product service interface also. Same way we need to implement the fallback method in product service interface also. Okay, circuit breaker annotation I am using. Name of that circuit breaker is external. I am providing this external name we can use in properties file, so that remember that name. Okay, fallback method I am providing as payment service. Sorry, fallback I didn't modify. Okay, product service fallback method. See, method default method I have provided here. Default void product service fallback. This method name is exactly same with this method name. Okay, product, small product we need to provide. Yes, here we are returning that message is product service is down. Please try after some time. Here in product service we didn't implemented the exception handling, so that I am using that throws exception and throw new exception of I am sending that only message only. Okay, we are not sending any error code. Okay, you can observe. Okay, yes, some properties we need to provide, right? Yeah, come here. Circuit breaker name we have used external. Same that name here also we need to use. These are the properties we can found in Google also. Okay, here what is the use of that? Event consumer buffer size I am providing. Event consumer buffer size. Buffer size of that events is in that buffer is 10 I am providing. Okay, register health indicator true. We need to check that health of that applications also, right? For all these properties we need to prefix resilience 4j dot circuit breaker dot instances dot external. External is the name of our circuit breaker. Okay, fine. These are the properties we need to provide. Sliding window size. size of that window is 10 only buffer events. Okay, when new event is created, old events are expiring. Okay, then that buffer size is window size is I'm providing as 10. Minimum number of calls we need to allow is 5. Whenever we are sending request, right, that minimum number of calls to that service is within specific time, 5 number of calls we are allowing. Permitted number of calls in half open state. Whenever the state of that application circuit breaker is half open state, then we need to allow only 3 calls. Okay, minimum is 5, max we can send anything. Okay, in half, whenever the circuit breaker is in half open state, we need to send only 3 API calls. Okay, automatic transition from open to half open enabled. Automatic transition from half open to open is true. Okay, we have discussed in this diagram, right? Same thing, that properties we are seeing now. Okay, automatic transition, yeah, this is true with wait duration in open state. Whenever it is in open state, request needs to wait, right? That wait duration is 5 seconds. Okay, failure rate threshold is 50%. That means failure rate threshold. That means whenever we are sending request to services, right, 50% of the services is success, 50% is fail. We can calculate like that. If it fails from open to half, the service request is fails, then it will transfer to half open to open also, then close to open also, right? Here, when it is in half open state, it will calculate the threshold value. When more than 50% of calls is success, then it is come to state changing state. Circuit breaker state is changed and come to closed state. Okay, that is the meaning of that. If you are not able to get that threshold, failure rate threshold, that property meaning, you can Google it. You can find that information. Okay, fine. I'll restart the applications, order service and payment service also. Then we'll test it. Okay. Order service is restarted and up and running. Now we'll test. See, I'm calling the get order details with ID 4052. We are getting response, right? I'm stopping order service now. No, we'll see the payment service also, or else product service. Okay. As for the product also, we are getting product details. I'm stopping that order service. How we will get response, we'll see. Sorry, we need to stop. Yeah, stop it, right? Yes. Service is done. Please try after some time. Like this, we need to send response back to client with some error message. Okay. This way, we need to implement the cloud gateway, API gateway and circuit breaker. If you really like this video, please like, share and subscribe to my channel. Thank you. Thank you for watching.